Welcome. Purpose of this video is to demonstrate autoregressive integrated moving average models, identification, estimation, unit root testing, and how to simulate AR-MA models using R. So for this you need to watch a couple of my previous lectures. At the moment I am going to describe it empirically so that you have better understanding. Due to this coronavirus, we may have to proceed for this maybe for next whole month or maybe 2 months. So therefore please keep on watching, do these exercises at your own. If you have any question, you can put me question on YouTube link. You can send me voice message on WhatsApp. You can send me through email. So let's move. So first of all, we have library read Excel, so that if you want to read any data, you must have this installed in your system. Library dplyr that I have explained in my videos on installing R and libraries. At the moment I am using library FPP2 and FPP3. You can Heidman book on econometric forecasting, forecasting for economics and business. You can download. We have been following this book for last 1 month, but due to disruption in classes, we are going to use it here. So first of all, I am using applied econometrics time series, Walter Enders, chapter 2 data, SIMS 2 data. So SIMS 2 data, if I read library and SIMS 2 data. So what is in this data? For this I have explained. You have a glimpse command to find out what is in this data. So we have glimpse, we have 100 observations, 4 variables. First variable is observations. The other 3 variables are y1, y2, y3. This is simulated data provided by Walter Enders in his book and on his site as well. You can see enders.net for this data. Okay, now we need to find out, okay, we just select y1, so आपके पास SIMS 2, and then we use this pipe operator, select y1. So in this y1 we have only data on y1. You can calculate ACF, PACF by directly writing ACF of y1, but at the moment I am using GGACF, grammar of graphics. I am using here ggplot library, so I am storing it in A1. Okay, and I am storing partial autocorrelation function of y1 in A2, in P1. I am using this library grid extra. If you don't have this one, install .packages and put here inverted commas and you will have this grid extra library. Now you see, I want to see parallel chart of A1 and P1, that is ACF and PACF. और इससे हमें बहुत ही useful, we can have very useful dialogue over it. Now you see what we have been talking here for last couple of days. This is autocorrelation function which decays geometrically very quickly after 7, 8, 9 legs, and here you see you have significant spike at first leg, plus minus 2 standard error, these blue lines, and one spike here at leg 10, 11, 12. If it's not monthly data, we can ignore and we assume it's by chance. 1 out of 20 can be by chance outside this range. So you have one spike here, geometric decay here. So what the model you will guess? Please think. So as per the table I have provided in my previous video, you see if this process decays geometrically and this process the PACF cuts off at leg 1, so it is process AR1. So we guess our model is here AR1. Let's estimate. You can calculate ACF and PACF exact values as well. At the moment I am going to skip. I will provide these codes. You can run these codes. So I am fitting model here ARIMA Y1, that is my series order PDQ. So P is 1, D we are not taking any difference, so it is 0, and we don't have moving average, so it is 0. And if you put these parentheses, just if you want to store data here, so it will be stored in fit. But if you put here bracket and obviously one parenthesis here, so you will get results here. So you see we have now AR1 is 0.72, its standard error is 0.06. So when we divide this coefficient by standard error, we see it's statistically significant. Now if you apply model AR2 model, then you can compare AIC corrected, BIC criteria on the basis of which you can have model selection. Now why I have been using I am using this FPP3 type of thing. So you see I am checking here what is my residuals of this fit. So look here, working here, yeah, that's interesting. Now if you look at these graphs, you have three things. One is residual plot, that is quite random, and you see ACF of these residuals, all autocorrelation functions are within this ±2 standard errors. So it means your residuals are well behaved, this model seems fine, and you have this one slightly different value, otherwise your distribution is also well behaved for these residuals. So this model seems apparently a good one. If you select AutoArima, means you ask this system R, eViews, Stata, some other software that select this model for you. Let's run this Auto.Arima Y1. It has also selected. It has selected. Oh, that's interesting. It has selected model AR1 MA1 and its AIC, BIC are 271.53 and 271.79. So now you can compare which model is good one, which model is both may be good, but which model is preferable. You can compare AIC, BIC values here. Let's again run this. So in this case you have 273 and in the previous case it was 271. So maybe ARMA11 model is better one anyhow. We have SIMS Y2 data that is also provided by Walter Enders, and you see here we select this one. Again we store autocorrelation function in A2, partial autocorrelation function in P2, and we have a grid here. In this case, you see, okay, we haven't given two columns, so therefore it is placing them side by side. N col equal to दो columns में if you display, then it will be, you see here you have a geometric decay, and here you have two spikes outside. So what the model will guess? We have mentioned that if ACF decays geometrically and the number of spikes PACF has, that will be your order of AR. So here we'll prefer AR2 model. But still you see in the previous Y1 we have fitted AR1 model, but ARMA11 was also a good competitor. So we don't know the exact model, we just try to pick the approximate model. You can apply here some other model Y1 MA12 like this. So these are table 2.2 of Walter Enders, chapter 2, applied econometric time series, what I am talking at the moment. So if we select AutoArima model, So it has selected AR1 MA1. AR1 MA1. If we select AR2 MA1 or if we select AR2, what happens? Let's see, we pick AR2 model, D is 0, moving average is 0. So what happens? And okay, in this case your AIC is 274. But one more thing, you see here 0.08 divided by 0.10, that makes AR2 non-significant. It means AR2 is redundant here, AR2 is no more needed, so you need to re-estimate this model. Anyhow, this is how we guess the model, then we estimate the model, then we check the residuals of that model, and if everything is fine, we say that is our model, but there can be more than one candidate model for one data. Now, another interesting thing that I'll describe in next video, that is simulated autoregressive integrated moving average models, as well as I shall explain unit root tests. थैंक यू फॉर वॉचिंग, टेक केयर. मैं वीडियो को शॉर्ट रखने के लिए इस वीडियो को यहाँ पे स्टॉप कर रहा हूँ. थैंक यू.